ladies and gentlemen, welcome to my class of physics. Today I'm studying about linear expansivity and I'm walking on a railway line. As you can see, the path I'm walking on is in between the rails. I know you are praying a railway or a train comes so that I knock it off, because you know the kind of strength I possess. But if you can see here, let us study. I've found something that we can look at. Here we want to talk about something about frictional force. Now, I don't know if you can see it clearly on my camera, but I hope you can see there's a shiny surface. This shiny surface is caused by frictional force, that it causes tear. That upper material of this metal is brushed off and leaves a shiny surface. That's why you can see some shiny. Now this metal is very strong. It's made up of iron, and iron is very strong. The metal is also mixed with some alloys so that frictional force is reduced. I hope you are seeing it clearly. And we also have a joint, an expansion joint. It is called an expansion joint in physics. Now when you learned about linear expansivity, we learned that you see a train is coming. You can see that train is coming. So when we learned about linear expansivity, we talked about the expansion of a metal on a linear surface. I don't know if you can remember that. If you can remember about linear expansivity, we say that when a metal is expanding linearly, it has to maybe increase in size in terms of length. Now this gap here is left out so that before I continue, you can see that train is going. I don't know if I can zoom clearly. Yeah, that train has gone. It was giving me a lot of goosebumps. Now this gap here is left out to allow room for expansion. When the temperatures are very high, this gap no longer exists. This is because the metal has expanded and occupied this space here. Are you seeing that? Thank you. Now there's another thing we can learn from this point. We can see how the metals are joined. So there we have some bolts and nuts. This is the bolt, this one that is round, and the nut is this one at the center. I don't know if you can see it. This is the nut. Yeah, the bolt, like a ball, B for ball. Yeah, this is the bolt. This one at the center is the nut. It is attached to this structure here. I don't know its name. This is some ballast. Maybe we can reduce them by throwing out there. We cannot. It must be sometimes. And then I don't know if I zoom clearly, there are also some other trains there. There you can see them. People are